Okay, so car repair costs continue to rise with an average cost now at about $367 per repair. So every time the car is broke, the car breaks, you have to take it to an auto shop to repair it. Is about $367 per repair. And we are making this assumption, assume that the cost is normally distributed with a standard deviation of 88. So what this sentence actually telling us is, we can use a bell curve to represent the cost, of a car repair. Okay, so that means whenever you see something like this, you should be able to use a bell curve to draw it, right? Very, very important. Okay, so this is a bell curve. I'm gonna label it out here. Okay, so first is, so this is gonna represent the cost of a car repair. We know it's gonna be a normal curve. That's what the question says. And do we know what the mean and the standard deviation is? Yes, the mean is 367 and the standard deviation is 88, right? This is great. Okay, so that means you can label your bell curve. Okay, so you can label it. Okay, I'm gonna do it here. Okay, so hold on a second. I want to have more space here. Okay, so let's see. Okay, so what you can have is, so I'm gonna label it here. I'm gonna label it as a 367. Okay, so this is one set of labeling. I'm labeling it by the actual observation because 367, that's the actual observation. You could also label it using a different way. You can label it by its corresponding z-score. What is the corresponding z-score for 367, which ends out to be the average? What's the corresponding z-score for 367? I'm going to give you guys a few choices. You want to think about it with me? Positive 1. Do you think it's a positive 1 here? Minus 1? Half? 0?
0.
Yes, right. You are right on the average, so that's going to be a 0. If you are not sure, you can use the formula I wrote earlier on regarding how you can calculate z-score. Remember, z-score is the observation minus the mean divided by standard deviation. Right? You can do the same thing. The observation you have is 367 minus the mean, which is also 367. That's going to give you a 0, right? 0 divided by 88. That's also a 0. So this is clearly a 0. Great. Okay, so what we want to do is we want to write out a very important information here is whenever you work on this word problem, it's essential that you write it out as a cost, which is, I'm going to represent it using x. X is a normal distribution with a mean 367 and standard deviation. Very, very important. You guys should always write it out. So to remind you, this is a mean, this is standard deviation. If you watched my video, you know that every time I do the same thing whenever I talk about each question. Very important. So draw the curve and write it out. Okay, so let's try out the first one, the first problem. Okay, so the first problem is, okay, what is the probability the cost will be more than $450? Okay, so we have to set it up first. Okay, so let's try to set it up. Okay, so we want to find a probability. Okay, the cost is more than 450, right? The cost, we want to find a probability the cost will be more than 450, right? So this is what we want to do. And we have already talked about how you can find a probability using z-table. But in order to use the z-table, you have to convert this number 450 to a z-score. Otherwise, you can't look it up. Because remember, for the z-table, you have two sets of numbers, z-score versus a probability. 450, this is not a z-score. This is clearly not a probability either. This is actually an observation. So you want to convert it to a z-score. So how are you going to convert it to a z-score? Do you remember what we talked about earlier today? The z-score, I'm going to type it out here. It might be easier and nicer. Okay, so that's going to be an observation minus the mean divided by standard deviation, right? That's the formula. So the observation we have here is 450 minus the mean. The mean is 367. So now you can see this line is very, very important. Divided by 88. So is this part clear what I'm doing? Okay, so what I'm trying to do here is I'm trying to calculate the standard deviation, right? Okay, so you can use your calculator. Make sure whenever you attend this kind of weekly meetings, make sure you have a calculator, you have your statistical tables, that means the Z tables, ready. And so so I've already done that, and let's see what answer we got. So you should calculate that. And okay, so I was able to calculate that one, and it is a 0.94. Okay, so let's go back to the graph we were drawing, 0.94. Okay, so let's go back to the graph. Okay, so this is what we have. Okay, so we want to figure out 450, right? 450. 450 is gonna be somewhere more than the mean, which is 367. So this is 450. That's gonna be 450. So this is 450 here. And so what we also learned is 450 has a corresponding z-score, and the z-score is 0.94. I'm going to just put the z-score in a bracket so you can see. So this dot here represents $450. It also represents the z-score, which is almost 1, but not yet, 0.94. Okay, good, 0.94. Okay, so what we want to do here is we want to figure out the probability to the right of it, more than that. So that's going to be this part, right? This part. Okay, so what you can do is you can look up 0.94. I'm going to remind you this is a z-score, and it's to the right of it, to the right. So whenever you look up the z-table gives you the probability to the left. So you want to use 1 minus that. So let's try 0.94. We're going to do it together. Okay, so 0.94. Great. Okay, so 0.94. Okay, so 0.94 is the z-score. Okay, so 0.94, that's right here, this number, 0.8264. This is a probability, but unfortunately, this is not the answer we need. We have to subtract it from 1 because we were talking about more than 0.94, right? And this probability only gives you the area to the left. If you're not sure, you can check out the z-table. The z-table, you can see it here, is to the left that's being shaded, right? Okay, so you want to use 0.8264. You want to subtract this number from 1, Okay, great. And so let's go back to the exercise we were working on. Great, so you can see it here, and you should be able to, yes. So you can see that's the number 1 minus that. This is how I solve it. Is it all clear? I mean, I understand this is probably not the easiest way to learn how to read the z-table, but I'm really glad that you guys are here with me. And okay, so I'm gonna skip part B, which is fairly similar. It says what is the probability? Again, you were asked to find a probability, so you probably have to use a z-table to do it. And you want to figure out the cost is less than to the left of 250. So the first thing is you want to convert 250 to a corresponding z-score, like what I just did earlier on, minus the mean divided by standard deviation. And now you're going to use the z-table to look for it. And you can find it right away because the z-table gives you the area to the left, less than to the left, right? Okay. So the only tricky part is, slightly tricky part is part C. What is the probability the cost will be? What is the probability the cost will be between this and that? So whenever you see between this and that, you know that you're probably looking for an area in the middle, right? In the middle. Okay, so I'm going to just draw it to remind you. Make sure you guys draw from brand new bell curve. Okay, so right in the middle, that's a 0 z-score. You can also label it alternatively using the actual observation. I think the mean is 300. I think the mean is 367. 467. Okay, good. So what you want to do first is convert 250 to its corresponding z-score. Okay, so let's do that. And okay, so you want to figure out the probability between that. Okay. And you want to convert 250 and 450 into their respective z-scores. Okay, so what did I do? Okay, good. So I convert them to their respective z-score. 250 has a z-score of minus 1.33. 450 is 0.94, which is, I think, what we just calculated here, right? We just calculated 450. So you have already done the calculation. You know it's 0.94. Okay, good. And we're gonna do next is, you probably remember this part, you're gonna look up the z-table twice. The first time you're gonna find the probability associated with 9.4. And then you're gonna find it again for the probability with 0.1 minus 1.33. And you're gonna use the bigger one minus the smaller one. Would you guys want me to go over this again, how I find those two probabilities, or do you think it's necessary?
I'm game if you do it again.
Okay. So let me do it again, right? So two z-scores we are looking for, 0.94 and also minus 1.33. Okay, yes, z-table, right? Okay, so two numbers I'm looking for. So 0.94, right? You guys remember 0.94. So if you look up for 0.94, the first number you have to write it down on a piece of paper, because you know there's going to be so many numbers. So you're going to write down it's going to be 0.8264. You guys see it here? Okay, so that's the first set of number you have to look for. And what is the second z-score we are looking for? I think it's a minus 1 point something, right? What is it? Hold on a second. Minus 1.33. Okay, so let's try it. Minus 1.33. Hopefully you guys are all still with me here. Minus 1.33 right here. 0.0918. Hopefully you're gonna write it down somewhere. Okay, so we have two numbers, 0.82 something, and another one which is smaller, 0.09 something. And you are gonna use the bigger one. Always use the bigger one minus the smaller one. The reason is because if you do it the other way around, the probability is gonna be end up negative, and the area under the curve can never be negative. So you have to use a bigger one minus a smaller one. So that's the trick for you to remember. Okay. Is this part clear what I'm doing? Is it all clear? Okay, great. Okay, so you can see the answers here. After you do that, you can compare with mine. So you can see how I did it. Right? Okay, just subtract those two numbers. And the final answer is not given here, but I'm sure you guys can calculate it. Okay, so there's one more question, which is, so another question, this is slightly challenging. Okay, so we're gonna work on this one, part D. Okay, so the part D, what D is saying is, for example, you repair your car and you realize you end up paying very little. The cost of your car repair is only in the lower 5% of auto car repair charges. So it's very little. You are on the lower 5%. And you were asked to find what is your cost. Okay, so before you jump straight into the question, you want to think about it. Okay, so there's a 5% here. So what is this 5%? Is this an observation? That means how much you pay for your car repair, which has a unit, a dollar sign. Or is it gonna be a z-score, which is whether 2 standard deviation or maybe minus 1 standard deviation below the average? Is it a z-score? That's the second option. And the third option is this 5% a probability? Okay, so you want to think carefully. The first option, 5%, is this an actual observation? That means how much you actually paid. It's 5% your actual observation, how much you paid. The second option is 5% a z-score? The third option you have is 5% a probability, or maybe an area under the curve. So what do you guys think? A, B, or C?
Probability.
Probability, right? C, right? Okay, so this is a probability, great. Okay, so this is a probability. Okay, and so in order to work on this problem, what you need to do is draw a bell curve. Very, very important. Okay, great. I've been repeating myself quite a bit. Okay, so I'm gonna hold on a second. I'm just gonna get more space. White space is precious here. Okay, great. Okay, so I'm just gonna. Okay, great. I'm gonna draw a bell curve. Well done, nice curve, right? Okay, good. So right in the center, that's gonna be the average cost. You can put 367 here. You could also put 0 here. There's two different ways of labeling them. They are equivalent. Okay, so you don't know where your car repair cost is, but it's gonna be along this line. It's gonna be along this line. If you're right here, that means you are paying average cost. Your car repair actually is the average cost. If you are somewhere on the right-hand side, that means your current repair cost is more than the average. You are paying more than the average. If your current repair is on the left-hand side, that means you are paying less than the average. So the question told you is a lower 5%. So where do you think it's going to be? Are you paying much more than the average or much less than average? Lower 5%. You are actually paying very little, right, compared to majority of people. So you are probably somewhere on the very left end. I don't know exactly where it is, but this is how much you pay. And we are going to draw the 5% on this diagram. So as some student was saying, 5% represents the probability. You can convert the 5% to 0.05. Okay, so 0.05 is your probability, right? Okay, I'm not going to try here. Okay, so 0.05 is your probability. Okay, so we're going to label it out. Okay, so I'm going to just draw it here. So do you think this part is 0.05 or maybe the area to the right is going to be 0.05? To the left, right? This small corner, that's going to be 0.05. Would you agree with me? So this area is 0.05. Okay, so you do have the probability. If you do have the probability, do you think you can figure out what is the corresponding z-score right here? You should be able to do it, right? Okay, how are you going to do it? You are going to read it from the z-table. Okay, so that means you're looking for a z-score with a corresponding probability. That means the area to the left, 0.05. This is how you're going to find it. 0.05 is the probability. And let's try it. I'm gonna share my my table with you. Great. Are you able to are you looking at my z table?
No.
No.
Great. Okay, so we're looking for probability 0.05. Okay, so let's try. I've seen many students, instead of finding 0.05, they found 0.005. You gotta be really careful. Not a 0.005, right? Not in between those. It's 0.05, just 10. Okay, so let's try. Okay, so let's try. Okay, so do you guys see it here?
We can't see your table.
Oh, you cannot. Okay, you cannot. Okay, great. Thanks for letting me know. Okay, so I'm gonna do it again. Okay, sorry about that. Okay, here.
We can see it now.
Are you able? Okay, good, great. Okay, so we are okay. So I was telling the student, make sure you count the number of zeros right. Even though it sounds like a really small thing, but I've seen a lot of students making this careless mistake. So we're looking for probability. So it's gonna be a number in the middle, not here, not the first column. This is the z-score. We're looking for a probability of 0.05. So you probably see it here, right in between, right? Do you guys see it? So there are two. I mean, I don't see excuse me. I don't see 0.05, but I see 0.0505 and 0.0495. Those two are fairly close. I'm going to ask you to think carefully. Which one is closer? If you don't see the probability you are looking for, you're going to use the one that's closer to it. So I have two numbers which are fairly close to 5% we're looking for. Which one is closer? Or maybe they are equally far away from it.
Would you consider 0.0495 to be closer because you round up?
Well, I mean, if you round up, okay, so let's try. If you round it to 2 decimal places, both numbers are going to give you the same number. For example, if I round this one to 2 decimal places, that's going to be 0.05, right? Because 9 is more than, 9, you round up for 9, so that's going to be 0.05. If you consider this one, you round it to 2 decimal places, that's also 0.05 because you have a 0 here on the third digit. You round down, so that's going to be 0.05 as well. Right? Okay, if you think carefully, those two numbers are equally far away from 0.05. Okay, so what that means is you are going to use their average. Okay, what I meant is you're going to use the average of their corresponding z-score. So let's try it. Okay, so for the first one, the corresponding z-score is a minus 0.164. Okay, so that's a minus 0.164. And the second one over here, that's minus 0.165, right? So that's going to be the average 1.65. So what is the average of that? The average is going to be 1.645. And that's the z-score you are going to use. Minus 1.645. That's the z-score you are looking for. Is this part clear? If you found, okay, so if you're looking for a probability, but you don't see it on the table, you're going to use the one that's closest to it. If you see two numbers, two probabilities that are equally far away from it, you're going to use the average of their z-scores. Okay, I know it's a, especially if it's the first time you see z-table, the first week you see z-table, it might be a little bit confusing, but after practicing a little bit using your homework, and hopefully you guys are going to become an expert to it. Okay, so let's move back to the question we were working on, and let's see. Okay, so I think I was working. Okay, so I think my the curve I drew earlier on disappeared here. That's okay. Okay, so that's a 0, and we know that for this part that's going to be minus 1.645. But you are not done yet for this problem because you were asked, what is your cost? So cost is an actual observation, and minus 1.645 is only a z-score. You have to convert this into actual observation, right? You have to convert it to actual observation. How would you convert it to actual observation? How would you do it? What's the actual observation?
Just by the way, we can't see the question. We're just looking at the z-table right now.
Oh, really? Okay. How about now?
There we go. Yeah.
Great. Okay, so let's go back to the question I was talking about. So we figure out the corresponding z-score is negative 1.645. How would you convert it to actual cost? Okay, so what you can do is you can go with the definition of a z-score. Okay, so z-score is 1. That means you are 1 standard deviation above the mean. Okay, so let's see. So we know that the mean is 367. And we also know that the standard deviation is 88. Okay, if it's a 1 standard deviation above the mean, what you need to do is you're just going to use 167 plus 88 times 1 because it is 1 standard deviation above it. But that's not a problem we have here. The problem we have here is minus 1.645 standard deviation. So that means I am actually 1.6 standard deviation below the mean. So that means I should use the mean, subtract 1.645 multiplied by 88. Is this part clear? Okay, so you want to use the mean, subtract 1.645 times 8. And if you do this, you should be able to figure out what the actual observation is. I think, do I have it here? Okay, so I'm going to display the answer so you can see. So it should be about 222, right? And you can also make sure you add a money sign to it because this is how much you actually paid